We tend to think of skin color as just, well, a surface trait. But what if it's actually a story? A profound biological record of our ancestors' epic journey across the entire planet. This is the story of how our skin literally changed to help us survive, and it's written right there in our DNA. And that quote, it absolutely nails it. The science behind our skin tones is nothing short of epic. Honestly, it completely changes how you see yourself and really how you see all of humanity. It's a wild tale of migration, survival, and some seriously brilliant biological engineering. So it all comes down to this one central conflict. Sunlight, specifically its UV radiation, handed humanity a huge dilemma. On one hand, it's dangerous. It zaps a critical B vitamin called folate, which we absolutely need for healthy reproduction. But on the other hand, we can't live without it. Our bodies use that same UV light to make vitamin D, which is essential for our survival. Our skin color is evolution's ingenious answer to solving this puzzle. All right, so let's look at the first solution evolution came up with. We're going to start in parts of the world with intense year-round sun, where the biggest, most immediate threat was having all that precious folate destroyed. And this is what you get: the evolution of deep, ebony skin. This is the absolute pinnacle of melanin production. It's an adaptation found in populations from equatorial regions, and it is basically nature's ultimate defense against a relentless sun. And get this, the effectiveness of this biological shield is just staggering. We are talking about blocking around 95% of all incoming UV radiation. That's a performance that rivals some of our best modern high SPF sunscreens, and our bodies just figured out how to do it naturally. Incredible. So this really gets to the core of why that shield was so important. It was never just about preventing a sunburn. See, that intense UV can literally break down folate in the blood vessels just underneath your skin. And if you don't have enough folate, reproduction can fail. So dark pigmentation evolved, first and foremost, to protect this crucial resource. You can really see that finely tuned balancing act right here. You've got deep ebony skin blocking a massive 95% of UV, then mahogany brown at about 75%, all the way down to fair skin. Each level of pigment is a very specific compromise, engineered for a very specific environment. But what happens when our ancestors packed up and moved away from the equator to places where the sun was weak and often hiding behind clouds? Well, the evolutionary problem completely flipped on its head. Suddenly, the challenge wasn't about protection anymore. It was all about production. And this is the result: very fair skin. This adaptation evolved to do the exact opposite of dark skin. Instead of blocking UV radiation, it's designed to let as much in as possible, to literally soak up every single available photon of light, to maximize vitamin D production. And the stakes for this? Unbelievably high. Without enough vitamin D, you get these devastating diseases like rickets, which causes bones to soften and deform in children. For those early populations moving north, being able to make enough vitamin D in low light conditions was, quite literally, a matter of life and death. You know what's truly shocking, though? The speed at which this all happened. Genetic evidence shows that the major shift to very light skin in parts of northern Europe happened in just the last 5,000 to 10,000 years. In evolutionary terms, that is the blink of an eye. It just shows you how intense that selective pressure really was.
Okay, so we've seen the two extremes, right? The folate shield and the vitamin D engine. But what about all the beautiful shades in between? This isn't just some simple gradient. It's a whole collection of sophisticated systems designed for managing sunlight that changes with the seasons.
Skin tones like olive or golden brown are perfectly adapted for climates that have real, distinct seasons. Think of places around the Mediterranean. They have just enough melanin to offer protection during a bright, hot summer, but they're also light enough to make plenty of vitamin D during a gray, cloudy winter. And this is where their dynamic strategy comes into play. Tanning. It's not just a cosmetic thing. It is a rapid, temporary adaptation hardwired into our biology. As the UV gets stronger in the summer, the skin quickly builds up a protective shield. Then, as the sun gets weaker in the fall, that shield fades away to maximize vitamin D production for the winter. It is such an elegant solution. All right, now for the final, and I think most mind-blowing piece of the puzzle. We've spent all this time looking at the differences, but the most amazing discovery is what connects every single one of us at a deep biological level. This is the fact that changes everything. Every single human on this planet, no matter what their skin color is, has the same number of melanocytes. Those are the little factories that make pigment. Just let that sink in for a second. The number of factories is identical in all of us.
So if we all have the same number of factories, what makes the difference? Well, it all comes down to programming. The variation is in how active those cells are, how they package the melanin into these tiny granules, and then how those granules are distributed throughout the skin. It's the exact same machinery, just calibrated differently by evolution. And this calibration, this programming is happening all the time. Like we saw, skin color is one of the most dynamic traits we have. It's not some fixed ancient feature. It's constantly responding to the world around us, which is just a powerful demonstration of natural selection in action. But the story goes even deeper than that. Evolution didn't just give us a different paint job. In some populations, it tweaked genes to make our cells more sensitive to vitamin D. In others, it created more efficient proteins to transport it through our bodies. It didn't just change our skin, it rewired our entire relationship with sunlight. So, the next time you look in the mirror, just remember that you are looking at a living document. Your skin tells an incredible story of where your ancestors lived, the challenges they faced, and the amazing ways they adapted to survive. It's a 200,000-year-old story that connects every single one of us.